Hello, so my name is Yash Chaturvedi, and this is my presentation for my final project for my class AAI 501 Introduction to AI from University of San Diego for their Masters in Applied AI program. So this project is basically we aim to perform sentiment analysis on Amazon product reviews for their home improvement category. And we will be using natural language processing techniques and machine learning algorithms to classify each review as either positive or negative. The results of this project can be used to understand customer sentiment towards products in this particular category and provide insights for companies to improve their products and services. So here is my video presentation link, my GitHub link, and my dataset link. Once I make this video and upload it, I will be adding the video presentation link to this slide and submitting it. So if you want to check any of these out, you can go through these links. So for the introduction, we already mentioned how we want to perform sentiment analysis on this data set, and the purpose of this project is to basically the scope of this project includes pre-processing the text data, applying different techniques such as bag of words, n-gram models, and deep learning models like different versions of RNNs, and then evaluating the performance of these models using cross-validation and accuracy metrics. In this project, I adapted published algorithms for sentiment analysis and applied them to this data set and addressed several problems and issues, including text preprocessing, feature selection, model selection, and hyperparameter tuning. These problems and issues are related to techniques and ideas covered in this course, including topics like text preprocessing, classification algorithms, and deep learning models. And so these are the four kind of what make the backbone of this project: the data preparation, the data cleaning, the exploratory data analysis, the language models and their implementations, and finally the model evaluation. And let's get deeper into this. So for the data preparation and cleaning, in the preparation part, this dataset had a lot of columns, and I only wanted to include the relevant columns, and so I chose 4 of them, which is review ID, review body, star rating, and verified purchase. To make the computations faster and spend less computing power, I also only worked with a sample of the full dataset. The full dataset had about 2 million reviews, and I chose a subset of 100,000, which was sampled randomly from this. And finally, we also work with tokenization and stemming the reviews. So tokenization involves breaking the text into individual words or tokens, while stemming is making them or reducing them to their root form. And these steps can help us improve the number of unique words in the dataset and therefore increase the accuracy. While cleaning, I perform generic cleaning steps, which include removal of any missing or null values, removal of any duplicates, removal of any irrelevant or erroneous data, and we also converted the relevant columns to the correct data types. For example, sometimes star rating was 5.0, sometimes it was 5, so we wanted it to be consistent, so we changed it to a certain type, and performed additional data cleaning steps according to the model that we were working on. So let's dig deeper. So first we did some exploratory data analysis, and this is a very summarized version of what we did, and you will see all the plots in the report itself, but I've included 2 of them here. The first one was the mean star rating by verified purchase. So we know we had a column verified purchase where if a reviewer had purchased something, and they would be considered a verified purchaser, and their reviews should actually add more importance. And therefore we, like right now we have like almost a 50-50% between the verified and non-verified percentage of reviewers, and we can see their mean star rating is 4 and 3.5. And the distribution of star rating is something I want to pay close attention to, as we can see that it's not properly balanced. So there are a lot of 5-star ratings as compared to the others, and so we'll see how this might affect the machine learning algorithms that we're going to work with. So the language models and the deep learning models I implemented were, first I did a bag of words model with the help of the naive Bayes algorithm, and I also implemented the n-gram model also with the help of naive Bayes. Third, I had an RNN, the recurrent neural network, with word embeddings as their input, and this specific implementation was for a GRU, which is a very common algorithm for text classification. And finally, we have another RNN with the same word embeddings as the input, but this time we work with LSTM layers. So the preprocesses for the data models. So in order to feed this data, what we have into our models, we did some preprocessing on it. So for the bag of words and the n-gram models, we did feature selection. So we actually created vectors for each review using term frequency, and we only selected the top 5,000 features. So basically the most commonly used. And we also drop words that are very rare or very common depending on their variance, and so we don't discriminate between the classes. For the GRU and the LSTM models, we had input as word embeddings, and we used the universal sentence encoder to create these sentence embeddings as we did in our homework, and we use these for the input to the neural network. And so this actually was taking a lot of time. So instead of passing all the reviews through this encoder at once, I performed batch processing, wherein basically you send in batches, and I chose a batch of 1,000 reviews for these encoding, and so this makes it computationally very fast. So we will implement this in this particular manner. And so this is basically like the result of what we achieved. So my classification models, like the first model I implemented was the bag of words model, and the bag of words actually didn't do very good. As we can see, the accuracy score came out to be a 4%, and this probably could be because of one of the limitations of the bag of words model, which is so the bad accuracy for the bag of words is probably because of the imbalance in the star ratings, as we had earlier mentioned that we discovered in the EDA that our 5-star ratings, there were so many 5-star ratings as compared to the other stars, and therefore that is a limitation of bag of words, and that is why we see this accuracy score. So another thing I wanted to actually first mention was, so we will be evaluating all these models on their accuracy, and accuracy is a commonly used metric to evaluate the performance of classification models. It actually measures the proportion of correct predictions made by the model. It is, to be precise, it is defined as true positives plus true negatives over the total true positives, true negatives, the false positives, and the false negatives. So that is like the total number of data points we have. And as we can see, the n-gram model gave us 86% accuracy rate. The GRU gave us 85%. The LSTM layer model gave us 78%. And this this shows us basically how each model was performing on this particular data set. And apart from this, we also, for the first two models, we also actually did cross-validation just to make sure that how it was how it was performing on the different versions of the same data set. So we did that, and the average scores came out to be pretty high for both of them. So even for back of words, it was around 70% something. For the n-gram models, it was also around 85-86%. But for the back of words model, the actual accuracy came out to be 4%. And this is probably because of overfitting. Sometimes the bag of words is not able to. So the bag of word model, I think, failed to generalize to new data, but did very well on the training data. That is what we could tell from cross-validation. So cross-validation basically is a technique that can help detect overfitting by splitting the data into multiple training and testing sets and then evaluating the performance of the model on each set. By taking the average score across multiple sets, we can get a more reliable estimate of how well the model is likely to perform on new unseen data. In contrast, when we evaluate the model on a single testing set, we are essentially testing the model's ability to generalize to new data. If the model is overfitting, it may perform poorly on the testing set, leading to a low accuracy score, which is the case for the bag of words model. And as I already mentioned, the n-gram model performed the best, and the RNN actually also for the GRU also performed pretty decently, which was where the accuracy was very close to the n-gram model. And in our report, we've also included the limitations for each of these models and how they are better than the previous model. So you can go through this. I think it will be out of the scope for this presentation, but it is a very good understanding if you go through that. And the last slide would be conclusion and future ideas. So some future ideas for this project would be, first, we could incorporate more features. So in addition to the text data, there are other features that can be useful for the sentiment analysis, such as like the metadata that was present and the user information and time-related information. So all of these will make our model more precise, and therefore this could be a future idea if we want to implement this and have a better accuracy. We can also deal with the imbalanced data. So in this project, we observed that the distribution of star ratings was not uniform, which could affect the performance of the models. So to deal with this issue, we can use techniques such as oversampling or undersampling to balance the data. And in the future, we can also do a real-time sentiment analysis. So in this project, we focus on analyzing a static data set of reviews, which means the reviews weren't changing. We had a set of data set which would not change. But however, in practice, reviews are generated continuously, and sentiment analysis needs to be done in real time. So finally, finishing this project, I think the most suitable models for this project and this kind of analysis are going to be GRU and n-gram models, based on at least what we found here. But I think there are very nice large language models present out there like GPT-2, GPT-3 and BERT, and which can, maybe they will take a longer time to compute, but they will be for sure way more accurate and will be able to generalize on new data in a more accurate fashion. And I think that will be the next step for this project. And this is the end for this presentation, and please let me know if you have any questions. Thank you.